Good morning friends. Today I am going to explain the most important topic of mechanics, that is work energy theorem. So before going to talk about this theorem, first of all we should know what is work and what is kinetic energy. So where work means what? That is the product of force into displacement. Here when some force is applied on a body to move from one position to another position, so that time we can say that is work is done. So that is force is a product of force into displacement. How much displacement? Here displacement is S. Okay. Here what is kinetic energy? The energy which is possessed by a particular body by virtue of its motion. So kinetic energy is can be given as 1 by 2 mv square. So now here you should have to remember these 2 points. Next, our theorem is what? Our statement is what? This one. According to this theorem, the work done by a force on a particle is equal to the change in the kinetic energy of the particle. So according to this theorem, here whenever some work is done on a body to move from this position to that position. So when work is done on a particular body to move from one position to another position, let us suppose first position is x1 and second position is x2. So that time whatever be the change in energy, let us suppose at this position the energy will be 1 by 2 mv1 square and the final stage will be 1 by 2 mv2 square. So the change in kinetic energy from one position to another position, so the change in energy will be equal to the work done. What it says, that is according to this theorem, the work done by a force on a particle is equal to the change in the kinetic energy of the particle. Here just I told you, let us consider a body which is moving from one position to another position. It means some work is done on the particle due to which it moves from x1 to x2. So when it is moving from x1 to x2, so it possesses some kinetic energy, half mv1 square and half mv2 square, let us suppose. So that time the change in energy must be equal to the work done. We have to prove this one. So to prove that one, let us consider a body of mass m is acted upon by a resultant force F along the x-axis. Suppose the body moves from a position x1 to the position x2 along x-axis. Let the velocity of the bodies is increases from v1 to v2. So just now I told you, that is, let us suppose a body is moved from x1 to the x2 and the body is having a some mass, that is m. So when it is moves, then the velocity also changes, that is from v1 to the v2. So that time the work done by the force is can be written as, the work done by the force is can be written as W is equal to from which position x1 to x2, and we know that work is nothing but a product of force into displacement. Here displacement is represented by a letter small dx. So here first of all we have to calculate the small dx, it means small displacement. Next, if you integrate to that one, then we will get the total displacement of the particle. Here x1 to x2 f dx. Let us take this is equation number 1. Now from Newton's second law. So what is Newton's second law? That is F is equal to ma. So product of mass and acceleration. Here a can be written as, acceleration can be written as dv by dt. So and we can write dv by dt as dv by dx dot dx by dt. Again dx cancel, we will get the dv by dt only. Only to calculate we are introducing dx or multiplying the dx above and below, numerator and denominator, or we can write m into dv by dx as it is. We know that dx by dt is nothing but a velocity. The differentiation of distance with respect to the time can be given as velocity, or you can write here dx by dt is equal to the velocity. Now we can write total form m is F is equal to mv dv by dx. Just simplifying that equation only from equations 1 and 2. Just we have to substitute the equation 2 in equation number 1. So equation number 1 is what? X1 to x to f dx. So at f position we are substituting the value of equation number 2, that is related to f only. So mv dv by dx dot dx. Now dx get cancelled, then we will get m taken outside. Now here v dv is there, so that's why the limits also changes from x1 x2 to v1 v2. So that's why m is equal to v square. If you integrate to this equation, it will be v square by 2. Then v1 to v2 is the limits. When you substitute the limits, then it becomes 1 by 2 m v2 square minus 1 by 2 m v1 square. So 1 by 2 m v2 square is what? That is nothing but a kinetic energy or final kinetic energy of the particle. And this is 1 by 2 m v1 square is the initial kinetic energy of the particle or body, whatever. Then the total work done is can be written as the change in kinetic. This is the equation for work done only. So and we proved that this work done is equal to the change in final energy into initial energy. So change in energy is nothing but a can be written as delta k. So if delta k be the change in kinetic energy, then delta k can be written as k2 minus k1. So simply this is replaced by k2 minus k1. Then that can be written as W is equal to delta K. So that is work done on the body by a force is equal to the change in the kinetic energy of the body. This is known as the work energy theorem. Thank you. For more videos, subscribe my channel Physics.